Okay, so we're talking about sorting and we're talking about quick sort. So what we just said is quick sort, okay, actually works on your divide and conquer technique. Okay. Divide and conquer means conquer is you divide the data set into smaller part, okay, and then try to solve it and then try to fix it. So here we pick an element as pivot element. Pick a pivot element. Now you can create a rule about pivot element. What rule you can create? You can create a rule saying that pivot element, okay, first number is always the pivot number, right? You can say first number is always the pivot. Or you can say last number is always the pivot. You can have a random also. You can select random, you can select median, okay, or maybe mean, something which is around mean. So you take the mean and then something, the number around mean, okay. So there are multiple ways to take pivot, but that doesn't matter, okay. You take one element as pivot. After taking one element, go through the list and subdivide the list. Divide the list based on this pivot value. Okay, so you'll end up getting left list and right list. So left list are numbers less than the pivot. So these are numbers less than pivot, and these are numbers greater than pivot. Keep doing it till you are done with all the elements. Okay, so it will be sorted. Okay, so if you want to see the code, we can we can see it. Okay, so what I'll do is let's first take the data. Okay, so you have list 1 equal to, let's say we put in reverse order 90, 80, 90, 80, 70, 60, 50, 40, 30, 20, 10, right? Okay, we have taken this L1. Now, size of this is going to be len of L1, right? Okay, right? And now we'll perform your quick sort. So how do you perform quick sort? Okay, so let's write a function to perform quick sort. Okay, now the function, okay, we need to pass, of course, the list, and you have to pass the number of the list, right? So let's create a quick sort here. So I'm going to say def quick sort algo. Okay, now this will pass the list. Okay, L1 will pass low comma high. Okay, initially what is low comma high? Okay, so initially your low comma high is going to be, okay, we'll call the quick sort, and initially your low comma high, okay, so size is L1, of course. Your 0 is the 0 index, first index. Okay, and then your len minus 1 or size minus 1 is your high index. Okay, and let's say this will return data, sorted data, and this should be our sorted list, right? Sorted list is going to be this one, data. But let's go back and add the logic here. So obviously, how long this has to go? As long as low is less than high. Yeah. Okay, 0 has to be less than the maximum. So you are looking at this. Now pivot, element. How do you do the pivot element? Okay, so pivot element, okay, we can okay, we can always say that pivot element is, let's say, your low value, because see, your quicksort will run on multiple, right? It's a recursive, right? So you have to divide this into every step. You're dividing into multiple smaller list, correct? So I will say that here, okay, your pivot, okay, is pivot element is going to be your, let's say, low. Okay, that means we are saying that your pivot element is always the first value.
Yeah.
Right? So pivot is first. So now you have to divide this, right, into two thing. So what I'll do is we'll create okay, so we'll create okay, so just thinking, okay, this is where we need to partition the data set. Okay, this is where we need to partition the data set, and so this logic will come here. Okay, so this is logic to partition the data set into two parts based on the pivot. Once you are done, okay, now you perform again QuickSort. So this time, okay, it is going to be your L1, okay, and we'll calculate the L1 in some time. L1 low and pivot -1. Okay, pivot okay, so pivot is the element which is partitioning, right? So what will have, pivot will be in center now. Right now it is low, but after this logic, pivot will be somewhere in the center, correct? So we'll say pivot -1. Now if pivot has reached the first element or the first element, then obviously this will not work, because low will be higher than the pivot then in that case. Okay, so this is to okay we are partitioning the left sublist. Similarly, we'll partition the right sublist. Recursion, right? This is how recursion works, right? And I'll say right sublist. So you have here, you will have pivot +1, okay, to high. Okay, so this list is done, but now let's come to this logic here. Okay, we'll add this. So how does this work? Okay, so I'm saying pivot equal to low, okay, or pivot will be the element, right? So I'm going to say pivot equal to L1 of low.
Okay.
Okay, L1 of low. Low is the first value. So I'm saying L1 of low is your pivot. Okay, great. Now I, okay, which will iterate, okay, equal to low -1. Okay. Okay. Now I'll write a loop again for J in range. J in range, low, comma, high. Okay, so I'm going through low and high. So initially, first time it will go from entire list. Second time it will be the sublist. Okay. So J in range. Now I'm saying if L1 of J, if L1 of J is less than equal to pivot, then it should be on the left side,
Left side.
right? So if if element J is less, then we need to pivot. I mean, we need to interchange, isn't it?
Yeah.
So I is initially 0, I mean -1, right, to start with. Now I'm saying I is I plus 1. Okay. And we will interchange the value. L1 of I, which is the initial low value, L1 of I, okay, comma, L1 of J, okay, equal to L1 of J, comma, L1 of I. So we are interchanging these values. Okay. Okay. So this interchange is done. Next what?
Next.
Now we have to swap the pivot element with the greater element. Okay. So I'm going to say L1 of I plus 1, comma, L1 of your high value. Okay. Equal to L1 of high, comma, I plus 1. Okay. Now the pivot should change. Pivot, okay, will be your I plus 1. Okay. Now let's see if this has worked or not. Okay. But how do we get this data? This is not returning anything, right? The QuickSort. So this is performing and yeah. So what I'll do is, let's put this L1 as global. If this L1 is global, so L1 will, we will be able to access this L1 here automatically. Okay. Let's see this first. Okay, this is based on my first understanding. Let's see if we get it right or not. Okay. No. But if I make it as, wait, pivot as high. Yeah. Now you see, we got the answer. So let's see what we did. Okay. Now see, that's what. See, when you're doing the program for the first time, right? Just try to focus on as best possible way you can do. Okay. And if you are not able to get it, then try to improve on it, because we have to have the first attempt done, right?
Yeah.
Okay. Now let's see what happens. Just like other day, we'll have a paint here side, and we will try to decode what we have done. So I'm going to share my entire screen. Okay, see this. So you have L1 this, right? This is the main logic. So initially you have L1, and you have low as 0 and high as 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8, correct? 9 minus 1, 8. If low is less than high, okay? As long as low is less than high, we should continue. Otherwise, that's the signal to stop doing partition, okay? Obviously, okay. So we are taking pivot as the L1 of high. So pivot we are taking is as 10.
Yeah.
Okay. So see, if we had taken low here, we should have used greater than sign. That's all. Okay. Okay. So now if you are taking pivot as L1 of high, high is 10. So your pivot is 10. Okay. First step pivot is 10. Now I is low minus 1. So I will become minus 1. So pivot is 10. I is minus 1. Okay. And now you are going through low to high. Low to high, J in range, low to high. So still it is first list right now. So low to high is going to be 0 to 8. Now again 0 to 8. Okay. This is first if condition, and this is loop 0 to 8. Now here you see what we are doing. We are saying L1 of J. J is what? 0. So if L1 of J is less than pivot, if 90 is less than 10, then interchange, right? If 90 is less, no, we are not interchanging with pivot. Pivot is fixed as 10. So if 90 is less than pivot, then I'm setting I to 1. Okay. That means we have got our first element, right? So we are starting with 0, and the moment you are getting our element, that see, I will change only when, see, when is I getting plus 1? I is getting plus 1 only when the value is, you know, this condition is true. Okay. If this condition is true, only your I is changing. That means you have got your first element now. Okay. So if L1 of J is less than pivot, if 90 is less than pivot, okay, 10, you got your first element. Okay. So here, obviously 90 is not less than 10, right? So this loop will not occur. So you don't go here inside if. And then you go back here. You take 80, 70, 60, all those things you keep taking. Obviously, you have not, this will not work because all these are greater than 10.
Yeah.
Right?
Yeah.
Then what you do, you say L1 of I plus 1. So 0, L1 of 0. First element is going to be your 10.
Yeah.
Because your high is what you got at the end, right? So now I'm setting 10 as L1 of 0. This is the, right now I is still minus 1 because we didn't go inside this condition. So I is still minus 1. So I of 0 became 10. Right? And L of high, okay, is what?
L of I is,
okay, is this position, correct?
Yeah.
And this has become I plus 1, 0th value. So 90 has come here.
Yeah.
So 10 has come here and 90 has come here. So when we took 10 as the high value, nothing got changed. And after the end of this, we have brought this one here. In the next step, I'm saying I is what? I is 0. I is still 0. Okay. Now we are saying pivot is this second element.
So 80 and 20 will change.
Yeah. Okay. So same thing now we have to do with 80. Okay. So this is after, if you had 90 as first, if 90 had pivot, this is what you have got. This is what you have got. Now it goes to here. Now here, what we are saying, we are dividing into two parts. One, low. Low is still 0, left side 0. But now you're talking about pivot minus 1. Pivot, okay? So this has become our pivot now.
Okay.
Okay, so this is one part. So, okay. So pivot is, I plus 1, 2. No, this is pivot, right? Sorry. Okay. This is I now, right? Minus 1. So this has become pivot. So this has become your one set and pivot plus 1 till high. So this has become one set and this has become another set. Now again you keep dividing. So now we are not going through the entire list, but going to the half of the list. So like that we are partitioning and we are going down. So if I take, okay, if I have to take low here, then the I should have been the high value. You have to go from high to low. So I is going from left side to right side to understand what values. See, you have already taken. So you are saying that this last element is your pivot element. So I need to know which elements are less than which should become, which all elements should come left of I. That's what. So I is tracking your left side element. Okay. And finally, we are breaking. So you have these left side elements here, and then you're dividing into two parts again. So this is your QuickSort. QuickSort, shell sort, and which was the other one? Merge sort.
Sort, yeah.
Okay. These are little different, okay, than each other. So in simplest of all the three is merge sort. You divide and then you join them together. Shell sort, you look at the partition, okay, and then you try to do the interchange, change the element based on the partition element. In QuickSort, we have a pivot element and we are comparing with the pivot. So if you see in a way, shell sort and QuickSort is doing same thing. Just that in shell sort, you have two, you are taking based on the partition, but your shell sort is taking, QuickSort is taking a pivot element and you are comparing with single element with other values. And then creating your left side and right side. Okay. So this is how the QuickSort works. So recursion is technique when, the function calls itself, right? And recursion will have one ending condition. Okay. So if, let's say, I write a function, okay, call sum, okay, so def sum n, okay, and okay, it takes an element, let's say 5. Okay, so you have 5 and you want to find sum here. Now if so it is sum of n natural numbers, right? So n is 5. Okay, I'll put n here. Okay, so it's like n is 5. So I want to find sum of n numbers. So sum of n numbers means 5, then n minus 1, then n minus 2, then n minus 3. Okay, so if I don't perform sum, if I have to call the same function here, I'll say sum of, okay, n minus 1. Okay, this is the example of recursion. So you have a function sum n which takes n value, and I'm calling sum n again with n minus 1. So it becomes 5, then 4, it'll call 3, 2, 1, and 0. And if you don't have stopping, it'll go to minus 1, minus 2, right? It'll go on forever. Okay, so if I call this, okay, sum n, right? So you'll see that if I say 10, okay, so starting is 10, fine, but then there's no ending value, right? So if I call this, you'll see it, there's about 1,000 times it can go in. Okay, after that it says maximum recursion, 996 times it has gone. After 996, it says maximum recursion depth exceeded. Okay, it's not able to go further beyond that. So your recursion should always have one stopping condition. In this case, where n is 0, that's when you
Mhm.
stop,
Mhm.
isn't it? So if n equal to 0, that's when you return. Okay, you return what? You return n. Okay, you return n plus sum of n minus 1.
Mhm.
So you're saying if it is 10, you return 10 plus 9. Now you have 9 also. 9 will return 9 plus 8, so on. And if it is not, if n is not equal to 0, then what? Then you simply call this function. Which function? You're returning n as n minus 1.
Mhm.
Okay, in fact, sorry, my mistake here. If n is equal to 0, that's when you return 0, in fact. You return 0. And if it is not 0, then you should return, okay, n plus sum of n minus 1. Okay. So initially n is 10. Goes here. Is it 10? 0? No, it comes here. So what it says, return 10 plus, okay. So what will happen here? You are saying return 10 plus, again call this function sum n.
Mhm.
So sum n of 9. This is what it means, right? 10
Mhm.
plus sum of 9. So it again it's calling here. So this is called now. When you call this again, it comes here, it becomes n. N is what? 9. So it
Mhm.
becomes 9 plus sum of 8.
Yeah.
Again 8 is called. So it is 8
So,
plus, yeah, 8 plus sum of 7. Okay. Now you keep doing it till n is 0. If it is 0, then you're not returning sum of 0. You're returning 0.
Mhm.
So like that, you see 10 plus 9 plus 8 plus n plus 6. So right, that's how you will be able to get this value. So if I say answer equal to, here it is print answer
Mhm.
55. So 10 plus 9 plus 8 plus 7, okay? N into n minus 1 by 2, right? That's the formula. 10 into 9 by 2. Is
Mhm.
it correct? No. 10 into 9, 90. No. 10, 9, n into n plus 1. So 10 into 11. So 110 by 2, 55. Okay. N
Mhm.
into n plus 1 by 2. That's the formula, right? So this is how recursively you are able to find sum of n numbers.
Yeah.
Okay.
Mhm.
Now if we talk about Fibonacci, see, recursion can only be used, okay, condition where you have, you have this possibility of function calling itself.
Mhm.
Factorial is very common example, and we did in the class, right?
Yeah.
Factorial is like you're saying 5 factorial. 5 factorial is nothing but 5 into 4 factorial, right? So
Mhm.
5 factorial is 5 into 4 factorial. It's the same example. Instead of plus, we are doing into. N
Yeah.
into factorial of 4. Factorial of
Mhm.
4 is 4 into factorial of 3. And instead of returning 0, you'll return 1, right? Because in factorial, if you return 0, it becomes 0, everything will become 0, isn't it?
Yeah.
Okay. So you're calling the function by itself. Okay. Okay. So, function calling itself, as I said, is called your recursion. Now let's try to do Fibonacci. Now Fibonacci, can we fit it into recursion? Okay.
Mhm.
Because the next number is addition of previous two number.
Yeah.
Next number is addition of previous two number. Next number is addition of
Mhm.
previous two number. That's the logic. Okay. So
Mhm.
there's a logic which you keep repeating every time. So yes, Fibonacci can be done using recursion. So let's say I write a Fibo. Okay. This is my function. And I'm saying give me n numbers, n Fibonacci numbers. Now see here, stopping condition. Always look for stopping condition in recursion. Otherwise, you saw what happened. So what is the stopping condition? Stopping condition is if you say n is 1 or less than 1. If I say 0 element, that's when you don't proceed. Correct? Or you say n is 1. Okay. So if n is less than equal to 1, then you say return n. Okay, return n. Okay, now else you have to call Fibonacci. So what is Fibonacci? Return, okay, Fibo of previous two number. So previous two number is Fibo of n minus 2, okay, plus Fibo of n minus 1. N minus 1, if it is less than 1, 1 or less than 1, it is this. That means here it will come only when you have 2 at least. Minimum n is 2. So what is Fibo of 2? Fibo of 2 is Fibo of 1 plus Fibo of 0. Fibo of 1 is 1, Fibo of 0 is 0, right? Returning n, right? So your 2 has become 0 plus 1. 1. 3 will become Fibo of 2 plus, okay? Now if I say, let's start with simple one. Let's say if I say Fibo, if I pass this, Fibo of 4, if I pass. If I say Fibo of 4. So what is Fibo of 4? Fibo of 4 is Fibo of 4 minus 2, 2 plus Fibo of 3. Correct? Which is equal to Fibo of 2 is again Fibo of 0 plus 1, isn't it? Fibo of 2 minus 2 is 0 plus Fibo of 1, and this is Fibo of 3 will become Fibo of 1 plus Fibo of 2. Right? 2. Now Fibo of 0 we know it is 0. So replace with 0 because we go to return n 0. Fibo of 1 is 1. Fibo of 1 is again 1. Fibo of 2 is Fibo of 1. 0. 2 minus 2 is 0 plus Fibo of 1. Isn't it? The Fibo of 0 is 0. Fibo of 1 is 1. So see, you get 1 plus 1 plus 1, 3. So Fibo of 3 has become 3, which is correct. Third element is 3 only. No. Fourth element, right? So first element is 0, second is 1, third is 0 plus 1, 1. Then 1 plus 2, 1 plus 1, 2 is your third element. 2 plus 1 plus 1.
2 plus 1 plus 1? No,
right?
2 plus 1 only.
2 plus 1 only, right?
Yeah.
The previous two number, right?
Yeah.
So 2 and 1. So you have 3. So now if I need to know what is the fifth element, okay, and now I want you to generate me Fibonacci series from 1 to 5. Okay, so I'll say for I in range, okay, 5 elements you want.
Yeah.
So 5. So if I say 5, here you say print, okay, Fibo of I, right? Fibo of I. And you want them in same line, then you can use end here, right? You see? So Fibo of 0 is 0, Fibo of 1 is 1, Fibo of 2 is 1, Fibo of 3 is 2, Fibo of 4 is 3. If you want 15 digit, you make it 15. It will go on up to 15. Okay? So function calling itself is your recursion function.